So we've done area under a curve before, but now we're gonna have two graphs in there. If it is right side up, which is all the ones we've done so far, it's gonna be a dx problem, and you will do the top curve minus the bottom curve. It's the upper minus the lower. Here's the only real curveball that like gets thrown at you here, is sometimes the graph is sideways, and you will do the entire thing in reverse. You will make it a dy problem, and it will be right graph minus left graph. Or if you just turn your paper like this, it's upper minus lower, okay? Here's the only thing, and no one ever likes this explanation. How do I know which one it is? You kind of just have to look at it and see if it's right side up or sideways. There's not a definitive answer for that. You need to look, do I have this graph above this one, or are they more next to each other? Now, the problem can give you a clue. If they give you one of the equations backwards, then it's like, oh, it's probably one of those backwards dy ones. But I don't have a good explanation for that. And you're going to have to just do a bunch of problems to practice looking at them. It's a thing that comes from practice, all right? So you learned how to graph without a calculator in pre-calc, and that's where that skill is going to come in handy. What is this graph going to look like? A parabola moved up to, all right, so we're going to go 0, 2. And you want to plug in some more points because you need the intersections exactly. So if you plug in 1, what are you going to get? 3, and then you get the buy one, get one point on the other side. And if you plug in 2, 6. Good, perfect. So it's going to look like this. All right, good so far. Y equals negative x. What are some points that I can put on that graph? I heard someone say 0. That's good. 0, 0. 1, negative 1 is good. 2, negative 2. Okay, and then does your slope instinct kick in there? At a certain point, your slope is negative 1, goes through the origin. All right, so something like that. All right, x equals 0. That's vertical line at 0. That's this. And x equals 1 is this. So this is the little shape that we're finding the area of. And everyone always makes fun of me because I'm such a nerd. That's cool, guys. That's neat that we can find the area of that thing exactly. Part of it's bent. It's cool. Get on board. Cool, guys. Neat. Neat, you can do that. All right. So we're going to set up an integral. This one is right side up. It's going to be a dx problem. Do you see how the parabola is above the line all the time? This one is above that one. Okay. What do you think your boundaries are going to be? 0 to 1. Do you see that there? Going from 0 to 1. You want to let your instincts kind of kick in here, right? 0 to 1. And it's going to be upper graph minus lower graph. So the upper graph is this one, x squared minus 2. Minus the lower graph, which is negative x, dx. I do realize that those negatives are going to cancel, but I want you to write it out like that because it is upper minus lower. It's a subtraction problem. So, oh, go ahead.
If we wanted to, could we still do like the integral from 1 to 0 s squared minus 2 and then another integral?
As two separate integrals? Yes. The only reason I would recommend against that is when you start doing more symbols and more notation, there's more room to make a mistake. But yes, it will work is the answer to that. Go ahead. Yes, thank you. That's a copy error. I knew you were going to call me on something as soon as I saw your hand go up. I was like, I wrote something wrong. Whoopsie. Okay, so I am going to take a step and cancel out that double negative there and make that a plus x. And again, after you do a bunch of these, I'm fine with you jumping to that step, but I want you to understand it's a subtraction problem since I wrote that up. Now you just do the problem. Now it's just do a problem. Once you get it set up, you just do the antiderivative. It's fundamental theorem of calculus. So what is our antiderivative here? Yeah, 1/3 x cubed, good, plus. See, you went fancy. You switched this around on me. I'll do that. I'll go with what you did, good. And then plus 2x, good, such that 0 to 1. Now it is upper minus lower. Often, not always, often the lower boundary is 0 And so I do skip it. But here's the thing you have to be careful of. Just because it's 0 doesn't mean you always get 0. And the one that trips people up is if there's trig, because for example, cosine of 0 is 1. E to the 0 is 1. So just be careful with stuff like that. But in this case, if you plug in 0 for all these, you get that you're going to get 0. All right. So really, we just need to plug in 1. So that'll give you a third plus a half plus 2, which in free response land is totally fine. Let's pretend it was multiple choice though, and they had like a simplified answer. What's your common denominator? Good, perfect. So, and thanks for not fighting me on that, because sometimes you got to get through that. It would be 2, 6 plus 3, 6 plus 12, 6. Good, perfect. And then you just add it all up. What is that, 17, 6? Beautiful. Which is the area of this little guy. Cool, neat, neat guys. Let's try it again. Find the area bounded by these two graphs. What is this one gonna look like?
Upside down.
Upside down parabola, also moved up 2. Okay, so again, we're gonna start at 0, 2. This one's just gonna be upside down. So if you plug in 1, you would get 1. Same thing on the other side. If you plug in 2, you're gonna get -2. Same thing on the other side. Oh, and also, you know how we did the below sea level areas were negative? When you do these, an area is always positive. It's not an accumulation, we're just literally finding the area of that shape. So all your answers should be positive, right? And then f of x equals x or y equals x. So what are some points I can put on that? Yep, 0, 0. Yeah, good. And 1, 1. And then hopefully your slope instinct kicks in. It's just up 1 over 1. So this is the area. We're fine. We're going to find the area of this little thing exactly. It's cool. Cool. That is kind of neat, right? Because so far, all you've been able to find areas are things that you have formulas for, like rectangles and triangles and trapezoids and semicircles. Now you can find the area of anything, which is where calculus like becomes applicable, you know? All right, so it's going to be a dx problem. It is right side up. Do you see how the parabola is above the line always? Like it's above, this one's above this one all the time. All right, so what do you think your boundaries are going to be? They need to be x values since this is going to be dx. Good, yeah, let that instinct kick in. It's from -2 to 1. Sometimes what I'll do is take another color and like bold those points. Those intersection points. I know the colors don't show up. All right, upper graph minus lower graph. So that's going to be 2 minus x squared minus x dx. And then you just do the problem. Once you have it set up, just do the problem. So what is our antiderivative? It's actually pretty similar to the one we just did. Good. And then minus 1/2 x squared, such that -1 or -2 to 1. Now this is kind of like womp womp. Neither one of them 0, so we're gonna have to actually do both of them. And I'm gonna have us fight through this. We'll fight through it until we get to an answer because I believe in you. And sometimes you have to be able to do it. All right, so upper minus lower. Let's plug in 1. If you plug in 1, you're gonna get 2 minus a third minus a half. Good. And if you plug in -2, you're going to get -4. What is that going to be? -2. Oh, yes. Oh my gosh, what is wrong with me? I'm sorry. Thank you. Oh, that won't change this though, because that was 1. Okay. This is still right though. Okay. -2 cubed would be -8. So the negatives are going to cancel. It'll be plus 8/3. And then this one, -2 squared would be 4. Half of that is 2, so -2. Now, however your brain thinks through this is valid. Here's what I'll do a lot of the times, though, is just recopy the first part and distribute the negative into that. Because a lot of times you'll get quote unquote like terms to go together. Like I noticed there's 2 of these terms that are thirds, and then you can kind of combine them. So that's why I do that. If you're like, no, my brain doesn't think of it that way, then do it your way. Like, at this point, we're just simplifying. So I gather all the whole numbers together. Tell me I didn't make another mistake with my negatives. No, those are all good. All right, so if we put all the whole numbers together, 2 plus 4 plus 2 is 8. And then if I kind of put the thirds together, this is why I do this. Negative 1/3 and negative 8/3 would be negative 9/3, which is minus 3. And then the last thing left there is minus a half. That's why I kind of do that, because then I feel like I can kind of put quote unquote like terms together. So 8 minus 3 is 5. 5 minus a half is 4.5. Or if you want to be fancy, that's 9 halves. But the area of this is exactly 4.5. It's cool. Cool. Yay. It is neat. All right, we'll do one more and then we'll do our halfway break. This one is the only one we're going to need a calculator for today. So I was figuring you could just watch me type it. You don't need a calculator for literally anything else we're doing today. So I wasn't going to make you all get them. I'll just type it and you can watch, all right? So find the area bounded by this thing. You're going to have to just plug in enough numbers until you get something that looks like a cube. Do you know what I'm saying? Like a wiggle?
Yes.
Okay. I would start with 0. If you plug in 0 to this, what are you going to get? 3. Okay, good. That was an easy one. Let's try 1. If you plug in 1, and I'm just going to write it so I don't lose track of what I'm doing. That would give you 1 minus 3 minus 1 plus 3. So 0, good. So 1, 0. Let's try 2. 2 cubed, 8 minus, all right, 2 squared is 4 times 3, 12 minus 2 plus 3. So negative 3, I think. Negative 3. I think if we plug in 3, it comes back to 0. I feel like that's where like the turnaround happens, but let me see if I'm right. If you plug in 3 cubed, 27 minus, yeah, I think I'm right, because that's going to also be 27 minus 3 plus 3, because that comes out to 0. So here's what we've got so far. The graph is going to go like this, come down, come back, but it's going to turn around, and I think -1 is where it hits the x-axis again, but let's just double check that. If we put in -1, that'll be -1 minus 3 plus 1 plus 3. So I'm right, it's going to come back there. So you get something that looks like this. So I knew there were going to be 2 bends in it since it's cubed. It's a wiggly thing. So you just, sometimes you have to do that. Sometimes life is like that, and you have to just, plug in numbers until you get it sorted out. All right, now it also says the x-axis. So you can kind of try to highlight the x-axis as well. X equals -1, so that's a vertical line here at -1. And x equals 2, so a vertical line at 2. So the parts that we're finding the area of are these 2 pieces here. And again, an area isn't negative. We're going to treat that all like it's positive. It's not like accumulation where you have like a below sea level thing that's negative. We just want the area of that shape. That's what we're trying to do here. So it will be a dx problem. What do you think your boundaries are? Just kind of let your instincts kick in. Yeah, -1 and 2, and they kind of hand you those ones. Now there's 2 ways you can do this, and I'm going to explain the easier way first because that's how I'm going to type it in. I would just go from -1 to 2 and slap an absolute value around it, and it doesn't matter which way you subtract them. Okay, now I would just do this one minus 0 because the other one is the x-axis, so it would just be this equation. So x cubed minus 3x squared minus x plus 3 dx. But here's the other thing you can do, and I recommend against this. You could go -1 to 1 of just that equation, and then you could add 1 to 2, but it would be the negated version of that. Do you get what I'm saying? It would be 0 minus that. You'd have to go and negate all of these. I say just do an absolute value, okay? So you guys tell me what to type. We'll just put this in and get an answer here. Math 9, -1 to 2, absolute value, the stuff. Yeah, I love that you guys come with me on the stuff, because in your mind, that's what you call it. I mean, you're not gonna. In your brain, you don't say all of that. Now we're gonna have to wait because it's gonna take it a few seconds here. It's thinking. There you go. Now, the calculator, if we worked this out by hand, we would actually get 5.75. Exactly. Okay. The calculator is less accurate than us. It is actually just 5.75 if we were to work it out by hand. But if you want to put 5.750 just to be extra thorough, and I agree with that because, you know, 3 decimal points, you got to do that.
How is it by actually putting?
So whenever it's sideways, you kind of just, it's such a crap explanation. You have to just kind of look at it and go, oh, that one's next to that one instead of above it. But you are given like a big hint here. Do you see how this is X equals instead of Y equals? That's like a big red flag. Hey, this one's backwards. It's going to be a DY problem. I don't know why, but over the years, I have learned that if I circle that part, it helps people. So I will, you know, usually do that. Also, when you go to graph it, I have found that it helps to make an XY table. If you're like, no, I can do it in my head, that's fine, as long as it's right. Because what we're going to do is plug in for Y and get X. Do you get that the whole thing is backwards? Okay, so I would start with 0. Do you see how I put that on the Y column? If you plug in 0 for Y, what do you get for X? 3. Okay, so you can plot 3, 0. As a heads up, it is going to be a parabola, but it's going to be
Like
flipped. Yeah, it's gonna be sideways. Oh, and before you're like, hey, but that's not a function. We're not concerned about that. That doesn't pass the vertical line test, fine. We don't care. We're just finding areas. All right. Then I would plug in 1 for Y. Now, whether I plug in 1 or -1, it's actually not gonna matter. Why not? So you're gonna square it, right? So if you plug in 1 or -1, what do you get for X? 2. Good. And then I'm gonna do plus or -2. Again, it won't matter because you're going to square it. So what would that give you for X? -1. Good. Now, when you plot the points, you still plot them forwards. Like that's still the point 3, 0. It's right here. You get 2, 1, and 2, -1. Again, it's not going to be a function. And then you get -1, 2, and -1, -2. I have to turn the paper to do this. Yeah, exactly. It makes everyone uncomfortable at first. It's like, it's sideways. You have to just kind of trust the process. All right, then we're gonna graph this one. What are some points I can put on this graph? Yeah, 0, -1. And then 1, 0. And then just keep going. It's gonna, you know, let your slope instinct kick in. And so this is the area that we're finding. So hold on, I want to bring up a couple of things. Just give everyone a chance to graph it and then look back up here. The reason it can't be upper minus lower, like, well, Ms. Cole, why can't we just do it as a DX problem and have it be forwards? For this portion, do you see how the line is above the parabola? But then at this point, do you see how the parabola is kind of like above itself? It doesn't work. It's going to have to be right graph and left graph. Also, throughout the years, I have learned that if I put an R here and an L here, that helps people right and left. I don't know why. I can't explain why, but I will have people that go, I just cannot see it. And then if I put the R and the L, they're like, oh my gosh, I can see it now. So like, I don't know why that works, but I'm also directionally challenged, so no judgments, okay? I've just found that it works. Now, if you have to do the whole problem backwards, you have to make a full commitment to the whole thing being backwards. So both of these need to be X equals. This one already is. You're going to have to do a little algebra for this one. How would you get X by itself here? Okay, good. So X equals Y plus 1. And again, I have found over the years, I don't know why, but if I circle that, it helps everybody. And now we're ready to set up the problem. Boundaries have to be Y values this time. You have to make a full commitment to the whole thing being backwards. I'll bold them here for you. It's those 2 intersection points, but you're going from here to here. You want Y values. -2 to 1. Good, nice job. -2 to 1. And it is right graph minus left graph. So do you see how the right graph is the parabola? That's the 3 minus y squared. Again, I found it helps if we circle that. 3 minus y squared. Minus, which one is the left graph? Good, y plus 1. And at the end, you're going to put dy. If at any point you have x's and y's mixed together, you have done goofed, okay? If it is x's, there should be a dx, and if there are y's, there should be a dy. Okay, so let's go ahead and sift through that before we actually do the problem, and I'll put it in descending order for you. It'll be negative y squared minus y, and then we would have 3 minus 1, so plus 2 dy. And then your antiderivative, negative 1/3 y cubed, I will write a cube this time, minus 1/2 y squared. And then the common mistake is people write plus 2x. And I totally get why that happens. I get it, but it needs to be plus 2y. Again, just look through, and if you have x's and y's jumbled together, then that's not right. All right, such that negative 2 to 1. For the sake of time, and because I'm not trying to torture you, I'm going to go ahead and tell you that the answer is 4.5. And how did I know that? That, and oh my gosh, isn't it the exact same as this problem except sideways? Cool. Well, I get the questions from College Board, so. Yeah. All right, so looking at this one, do you see how your big clue is that this is x equals? Oh, and what's really nice is this one is also x equals. So you don't have to do any algebra to rearrange them. You can make an XY table for this one if you want, but do you see how there's no other numbers in there? It is a regular old parabola except sideways. So if you want to just turn your paper and do a regular old parabola like 1, 1 and 2, 4 and 3, 9, do you get what I'm saying? Like it's actually backwards to that, but if you just turn the paper and do it, it'll make like a little bit more sense. Or you can make an XY table, you know, again, however your brain does it is valid. Now I will make an XY table for the other one until we get a couple points and the slope instinct kind of kicks in, because it is backwards and that throws everybody off. And you're like, well, it's super easy. I don't need a table. Yeah, you don't want to mess up the easy stuff, so don't be too proud to write it. So I'm going to plug in for y and get x. I always start with 0. If you plug in 0 for y, what do you get for x? 4. Good. And then I would do 1, like start with easy numbers. If you plug in 1 for y, 7. Okay, so like that's probably enough. If you plot those, you've got 4, 0, 7, 1. And then do you see how you could just keep that pattern going? Like keep the, yes, thank you. Okay, cool. Just like up 1 over 3, like let your slope instinct kind of kick in. And then this is the area that we're finding. But you don't have to color it in even if you're like, I don't want to shade it in. That's totally fine. Just understanding that's the area that we're finding. And it is sideways. I'm just going to bold the intersections there. It is sideways. If you're like, well, why can't we do upper minus lower and make it a dx problem? Can you watch me point to it? Because I want you to understand it. The curve is above the line for like all of this part. But when you get to this point, do you see how over here the curve is kind of above itself? It's not the same anymore. So that's not going to work, right? So now we're ready to set it up. You have to use y values. So I kind of bolded the intersections. What are going to be our boundaries? Yeah, -1 to 4. You guys are on top of that. Good. And then it's right graph minus left graph. And again, I don't know why this works, but I've just found that it does, putting the R and the L. Which one's the right one? The line, which is 3y plus 4. Again, I've found that circling that helps too. just by trial and error and having done this for every decade, I've found the things that work. Like when I try and explain it and someone doesn't understand, I'm like, well, what about this? And I just keep throwing stuff until something sticks, right? And then what would we put? Minus y squared, and then at the end, dy. All right, and we'll work this one out because it won't be too hard. All right, antiderivative. Oh, you guys go fancy. You want to do it in descending order. If you want to do that, it would be negative 1/3 y cubed plus 3/2 y squared plus 4. Oh, good, y, such that negative 1 to 4. You guys are purists. You're like, no, it must be in order. I'm kind of like, whatever. Oh, that's the algebra. And are you like that too? Like it must go in order. Okay, so upper minus lower. This one's gonna get a little nasty, but we can fight our way through it. As long as I wrote everything correct. All right, 4 cubed. So that's negative 64 thirds plus, all right, 4 squared is 16. 16 divided by 2 is 8 times 3 is 24. Plus 16, good. And now we're going to plug in negative 1. That would cancel and give you a positive 1/3. Plus 3/2 minus 4. Again, what I typically do in this case is distribute the negative sign. I don't know. That's what I do. You are welcome to like work through it a different way. That's totally fine. I just do that because then I can sort of gather what I call like terms. They're not really like terms, but I gather all the whole numbers and then all the thirds and then all the halves. I feel like it works better. All right, so if you gather all the whole numbers, 24, 16, and 4 be 44. And then the thirds. So that's not going to work out though. But how many thirds would that be? That would be minus 65 thirds and then minus 3/2. I'll let us end it there because what would our common denominator be? 6. Then I don't feel like turning 44 into 6. If that's okay with everybody, I feel like we'll just end it there. Okay.